Welcome to another video. So we're going to continue talking about how to graph some lines. Now, last time, what we really discussed was just the beginning on how we check whether points are solutions to a linear equation with two variables or not. And if they were on the line, and if not, they weren't on the line. And by using just the points on the line, those solutions, we can graph a line pretty easily. Now, last video, I gave you the points to check. In this video, we're going to continue graphing our lines with points by plotting points, but now we're going to learn that we can pick any points. We really can. We're also going to learn, and this is what I'm really trying to get you to know, is that this really isn't the best method. It's important for you to understand where these points are coming from and what we use them for, but I'm really trying to, have in mind one goal with this video, that there are better methods. And so what I want to start unpacking in the next like 2 or 3 videos is there's some better methods to do this. So as we graph this, I don't really care whether we're super great at plotting points. Yes, we need to do that, but I'm only doing this so that you can see how that formula relates to the picture that we're going to get. That's the big part. So keep that in mind as we go through this video. What these numbers due to this graph and how these numbers affect the graph that we're going to get. So let's start. We're going to continue plotting some points. Now, like I said, I gave you the points to check last time, but you need to know that you can basically pick whatever numbers you want for your variable. We usually plug into x. It's called our independent variable, not what we can choose to plug in. And we usually get outputs from our y, our dependent variable. It depends on what we pick for x. That's normally how we like these set up, solved for y. We're just used to it. That's how most of our linear equations in 2 variables are set up for us. So we can pick whatever we want, but use at least 3 points. Now here's the reason why we want to do that. If you only use 2 points, yeah, it only takes 2 points to graph a line, but what if you screw one up? You're not going to know. So we use 3 points to graph these lines, at least 3 points to graph these lines, so that if we mess one of them up, we'll know. We won't just go, oh, there's 2 of them, makes a line. We'll know if it's not a straight line. We know that we have to get diagonal lines out of these linear equations with 2 variables, so we want to use 3 points to make sure that we're actually not making a mistake. So let's pick some points. Now, the points that I picked, and I'm just making these up, so there's no real reason why I'm picking what I'm picking, besides I like whole numbers, besides I really want to know what happens at 0, and most of the time I pick a negative number. Necessary? Not really, but I don't want to start plugging in random things like 1.7. That's kind of awkward. So pick some easy points, easy values for you to plug in. -3, I want to see what happens on the left-hand side of the y-axis. So over here, 0, that's a really important point. What we want to find out, we talked about a few videos ago, is we want to know what happens on the y-axis. We want to know that, well, if we plug in 0 for x, that we're going to get where we cross that y-axis. That's a huge deal. That really tells us a lot about our graph. So I definitely want 0. By the way, it's easy. I mean, it's easy to plug in. I love plugging in 0. 1 seems like a pretty nice number. Let's try 2 and let's try 3, just so we can get a hang of what's going on. So let's start doing this. What we're doing here is we're picking a value for x. I'm just making these up off the top of my head. I do have some reasons for them, which I just told you, but you can use pretty much anything you want. To figure out the other half of our ordered pair, listen carefully to that. We're still getting points here. We plugged in 1 number, we're going to get a number out. That creates that pair, that input-output relationship. That's what we're going to use to graph our line. So let's plug in -3. Be careful with your signs. It's really easy to make mistakes on these, especially when you're plugging in negatives. So if you're going to do that, if you need to, pull it off to the side, take -3, and actually show your work. So y would equal 1's not going to change, minus not going to change, 2's not going to change. The x becomes -3. You're going to notice right off the bat that I use parentheses whenever I evaluate. The reason why is because it maintains our operation. It's still multiplication, and it also maintains the negativity. So it doesn't look funky like 1 minus 2 minus 3 if I don't have the parentheses. It's really awkward. Use parentheses. You almost can't overuse them. So, well, let's think about what this really does. If we use OR operations, cover this up, 2 times -3 is -6. We are 1 minus negative 6 at this point. That's what's going on. You can manipulate the signs however you want to, but you better get 7. You better get 7 at the end of this problem. So when we plugged in negative 3, we got positive 7 for our y. Negative 3 for x, our independent variable, is giving us positive 7 for our dependent variable. And we're going to go through in a minute and make some ordered pairs and then just plot them. That's really the process for doing this. First, we solve our equation for y. If it's already solved for y, you win on that step. Then we pick basically whatever points you want. At least 3 values for x. Always pick 0 if you can. Always pick 0. And then we're going to make some ordered pairs, put them on your graph, and hopefully you have a straight line. If you do, you did it right. If you don't, you probably made a mistake on a sign. So let's make sure that we're clear on the rest of them. Let's plug in 0. So I'm not going to do the rest of them on the board. You certainly can write them out. But let's plug in 0. Let's use our head if we can. If I plug in 0 for x, basically this whole term is gone. If I plug in 0 for x, I get 1 for y. If I plug in 1 for x, so 1 minus 2 times 1, that's 1 minus 2. Well, that's negative 1. If I plug in 2, well, that's 1 minus 2 times 2. 2 times 2 is 4. So 1 minus 4 is negative 3. And lastly, let's plug in 3. 1 minus 2 times 3. Okay, that's 1 minus 6. That's negative 5. Take some time right now, if you haven't done already, and make up ordered pairs. Your teacher, and if it's me, I'm certainly going to want to do this. I want to see that you understand the concept here. We're in beginning algebra, okay? So a teacher, whoever your teacher is going to want to know that you understand that these things pair up in a certain order and create a pair of numbers that we can graph, an ordered pair. Go through and list them out right now if you have not done that. So what I mean specifically is your input, your x, always is first, and your output, your y, is always second. So we get 5 points out of those 10 numbers. They each pair up. The first ordered pair is we plugged in negative 3, we got out 7. That's a pair. We have 0, 1. 1, negative 1, 2, negative 3, and 3, negative 5. Why we do that again is to show that relationship, and second, it's pretty easy to put those on a graph. So let's plot them. We know how to plot points. I spent a whole video on that. Let's plot the points, see what goes on. So I know that when I plugged in negative 3 on the x-axis, that's why we're creating these points. We plugged in x numbers, we got out y numbers. That gives us a distance on the x-axis related to a distance on the y-axis, a height on the y-axis. Kind of cool. So negative 3, 7 says left on the x-axis, negative 3, cool, and then up 7. A combination of those two moves, like a knight in chess. We're going to be right about there. At least it looks to me. Then we plugged in 0. Again, I cannot stress this enough. Plug in 0. You really, really want to find what the y-intercept is on these lines. It's important, and it's important for the relationship I'm going to draw for you in just a moment. So we plugged in 0, we got 1. That's the point. 0, you're not moving, and you're going up 1 on the y-axis. Combination of those ideas puts us right at that point. Then we have 1, negative 1. 1 on the x-axis gave us negative 1 on the y-axis. That relationship is right there when we plot that point. 1, negative 1. 2, negative 3. 2 on the x-axis combined with negative 3 on the y-axis. And lastly, we have 3, negative 5. 3 on the x-axis positive combined with negative 5 on the y-axis. It gave us that height. Right there, if you're looking at your paper, you're looking at the board, we should be able to pretty clearly see whether we've made a mistake on plugging in our numbers or not. We're graphing lines. If you ain't getting lines, you're doing something wrong. These are all linear equations. So we want to make sure that they actually do make a line before we start wasting our time trying to draw a straight line through something that's not straight. Now my scale's going to often be wrong on these lines. I'm hand drawing them. But that's pretty close. Put your arrows at the end of your line. This thing goes forever. And most people are going to label this like y equals 1 minus 2x. When you get to function notation, which means that you have f of x or g of x, if you've had some level of math before above this and you're kind of retaking this, you'll see that a lot. If we have that, instead of y, you have like f of x, g of x, h of x. If this is not making sense to you, do not worry about it. But if we have that notation later on, we would just label this line as f of x. We don't have to write the entire functions. One reason why we switch over to function notation in a little bit higher math. Now, I said something a little while ago. I said that I love that you can do this. This is great. But here's the point. Please get this. No one in their right mind would spend their time plotting points like this once they learn a better way to graph. All this is geared to do is to get you to understand the relationship between these numbers in a linear equation and the line that we're getting. Now, one way to see that relationship, always write your linear equation as solved for y. And always put it in order. What I mean by in order is I want the x term first and the constant term, if we have one, I want that last. So I'm going to take a moment and I'm going to rewrite this as negative 2x plus 1. Well, why do we do that? When we get something called slope-intercept form, if you know that form and you know how those numbers relate to your line, you can graph this thing in like seriously 5 seconds. That's the relationship I'm trying to get you to see. So notice this real quick. Yeah, we can plot points. Yeah, there's 5 of them. Do we need that many? Not really. We need at most 3 of them, so that kind of shortens our time. But second, check this out. I want you to right now put your pencil on the y-intercept, where this line, this diagonal line, crosses our y-axis. Put your pencil on that. I kind of illustrated this in the last video, but I want to make absolutely certain you see it. So put your pencil right on the y-intercept. What point is that? I kind of missed it. I'll make it bigger. What point is that? How does that point relate to our function, our line, our linear equation? Check it out. I talked about last time, but that number, that constant, if you have solved for y, solved for means isolated, there's nothing around the y, it's literally just y, equals x term plus constant. That constant will always tell you where your line crosses the y-axis. It is not a coincidence that positive 1, we think of that term as positive 1, the terms go with the sign in front of the term. So that positive 1 literally is that positive 1. Now why? Don't just write it down. Don't just remember it. But why? If you were to always plug in 0, which I told you to do, if you were to always plug in 0, think about this for a second. Plug in 0 for x. 0 for x is right here. It is the y-axis. If you plug in 0 for x, you are going to be on the y-axis. If you plug in 0 for x, this term is gone. If your x term goes away when you plug in 0 for x, you are only going to be left with the constant. 0, plug in 0 for x, plus the constant gives you that constant. So plug in 0 for x, and you're getting something on the y-axis. The constant is the only value left. So 0, comma, that constant is always your y-intercept. That's what's so valuable about solving for y. It lets you see the relationship very, very nicely. So that 1, that positive 1, is that 1. It gives you the y-intercept every single time. Now, what's even equally impressive, I guess, not more impressive, equally impressive, is what that negative 2 does. That number in front of the x, that's called the coefficient. And if you have that solved for y, that coefficient tells you how to get from point to point to point to point. And it is awesome. So, how we do it, it's called the slope. And I'm going to really illustrate this later. Remember, I'm just trying to get you to think about it now. You don't have to be perfect at it now. I just want you to think ahead. The slope tells you how much you go up or how much you go down compared to how much you go to the right, never to the left, never, always to the right, which means it's a relationship, kind of a ratio, which is a fraction. So if we write this as a fraction, this negative 2 over 1, you can always change a whole number into a fraction by putting it over 1. That number tells you your y-intercept, your constant, if you solve for y. This number, your coefficient, the number that's associated with your x, if you solve for y, tells you how to get from point to point to point. Your top number, your numerator, tells you to go up or go down, whether you have positive or negative. So positive would say up, negative would say down. Check this out, it's so awesome. How we would get from point to point to point is to drop 2 from point to point, and at the same time go to the right 1. The numerator tells you up or down, positive up, negative down. The denominator tells you how much you're going to the right. You never go left, ever. The positive versus negative only affects the climb versus the fall. The run is always to the right. Kind of like if you have water in Tijuana, you're going to run right to the bathroom. It's always run to the right. It's funny. And I've done that before. So here we go. So we're going to go down to 1, 2, and to the right 1. That's on the line. Drop 2 again. Down 2, to the right 1. That's on the line. Down 2, 1, 2, to the right 1. That's one of the points. Now, naturally, we didn't list every point on here. We can't. There's an infinite number of them. But it's always going to give you a point if you follow this slope. So from one point, follow the slope. This gives you another one. Let's keep on going. Down 2, 1, 2, over 1. Got it. Down 2, over 1. Down 2, over 1. You can do that for eternity, and you'll always be on the line. Ask yourself that question. Do you see the relationship between that constant and that y-intercept? It is the same value. Do you see the relationship on how it's called the slope, how the slope works? Create a fraction here. It will tell you up or down. The top number, the numerator, tells you up or down. The bottom number tells you to go to the right, that many steps, that many units. That's a big deal. Do you understand why we have to solve it for y first? If this is not solved for y, it would create a problem. Because in order to get that y-intercept, you can't have anything added or subtracted over here. You have to be able to plug in 0 and get exactly what y is equal to for that to work. That's why we have to solve for y. Now, before we even get going on this sucker, I want you to think about it. Is that solved for y? Okay, if you were to plug in 0, check this out. Plug in 0 for x. We're always really plugging in for x. Plug in 0 for x. You know what happens this whole term? That thing's freaking gone. If you plug in 0 for x, really recap this in your own head, okay? You plug in 0 for x, it's putting you on that axis. You plug in 0 for x, the only thing that you can possibly get is 3. I guarantee you we're going to be crossing this y-axis at 0, 3, right there. We have to. There's no way around it. It's solved for y, which means if you plug in 0 for x, it takes that entire term away, 1/2 times 0 is 0, and you add 3, that's 3, then when you plug in 0 for x, you're getting 3 for y. Does that make sense to you? Are you seeing what I'm talking about here? That's the idea. That's how the y-intercept is obtained from these linear equations in 2 variables. You solve for y, you plug in 0. That's why that's so important. So I know for sure that we're crossing there. One last thing, I'm going to kind of give it away now so that as we're building our points, you see what's going on. To find the next point, what would you think? Look here, it's already a fraction. That's kind of nice. Would you say that we'd be going up or would we be going down? Look at your numerator. Positive means that we're going up. How many spots would it be going up? Go 1 spot. And then we're always going to go to the we always go to the right. So from that point, so not the origin, okay? We're only going from the origin if our y-intercept is at the origin. We're going from our y-intercept at 0, 3 because the slope doesn't tell you how to get from the origin. The slope tells you how to get from point to point. That's kind of neat. So from point to point, from the point that we're going to get here, we should be climbing up 1, because it's positive 1 on the numerator, not the top number, and to the right 2. We should have another point somewhere over here. Let's see if that actually works. Just a little side note, you don't have to make your tables like this where x is on the top and y is on the bottom. A lot of times we make vertical tables, much like that. A lot of people put x over here and y over here, and the reason why we do that is because if you make a vertical table, it literally gives you your ordered pairs right down the line. All you gotta do is put parentheses around them. That's kind of nice. So, I also like to give you another hint. I told you that you can pick any numbers that you want, but a lot of times you shouldn't pick any numbers that you want. There's a few numbers that are going to be better for this particular example because we have fractions. The first number that I'd like you to pick all the time, just 0. Pick 0. It's such a nice number to plug in. It's easy. It gives you your y-intercept no matter what. That's fantastic. So if we plug in 0 for x, check it out. Y equals, let's leave the y, 1/2 times 0, that's gone. 0 plus 3, we've already talked about it. You're going to get 3. You literally get the y-intercept. Oh, shocker. We're going to be at that point like we talked about. That's awesome. That's why it works. I've already explained it, but that's why it works. So we're going to have a point, 0, 3. Notice how that makes your order pair for you, like right there, side by side. It's kind of nice. Now, pause and don't pause the video, but just stop and think for a second. I'm not going to put in 1. Why? Why wouldn't I plug in 1? Do you like dealing with fractions? Nobody likes dealing with fractions, okay? Nobody likes that. We don't have to that. Let's plug in a number that makes the fraction disappear. So plug in numbers that kill the fraction. Here's the easiest way to do that. Plug in the denominator of your fraction, or plug in a multiple of the denominator. So, for instance, I'm looking at my fraction, I go, I don't like fractions. No one likes fractions. Let's plug in, not 1, that'd give us a fraction. Plug in whatever that number is, so plug in 2. Don't plug in 3, but plug in 4, a multiple of that number. So we'd be plugging in numbers like 0, that's great, but 2 or 4 or 6 or 8 or whatever, something that 2 divides into, a multiple of 2. If this had been 7, you'd be plugging in 7, and then you'd be plugging in 14. Do you see what we're doing there? We're finding multiples because when you multiply a fraction times a multiple of the denominator, you're going to kill the fraction. It's going to be completely gone, and then you don't have to worry about graphing fractions. It's kind of nice, right? Let's change it back. So I'd be plugging in 2, and I'd also be plugging in 4 because I want to destroy that fraction. Let's try it. Plug in 2 on your own. If you can do it in your head, awesome, or take your calculator out with your fraction button. 1/2 times 2. That's 1/2 of 2. Well, that's 1. 1/2 times 2 is 1. 1 plus 3 gives you 4. And right there we have another ordered pair. We have an input-output. Let's plug in 4. Well, 1/2 times 4. 1/2 of 4 is 2. 1/2 times 4 is 2. 2 plus 3 gives you 5. How many points do you need? At least 2. But we want to do 3 to check our work. Because if you made a mistake somewhere on here, it would not show up with 2 points. 5 is kind of overkill. I'm just kind of illustrating this. But we really just need 3 points, at least 3 points. Now plot them. If you haven't done it already, spend some time. Plot those points. I'm going to put 0, 3 on the board. Over 0 and combine with the height of 3. The value on the x-axis of 0 gave us a height of 3 on the y-axis. A value of 2 on the x-axis gave us a height of 4. The value of 4 on the x-axis gave us a height of 5. Does that look like a straight line to you? Because it looks pretty darn good to me. That's awesome. That's the way you check your work. If I didn't have that point and I just had those 2, I'd be very much trusting that my math was rock solid. And I usually can, but if I had made some sort of simple mistake, well, it wouldn't show up. But if I did this, I go, well, that doesn't look right. That's the way you check your work. If you have a mistake on one of those points, it's going to show up with 3 points. That's why we do that. All right, so it looks like a straight line. Let's draw the straight line, a diagonal line through these points. We label it, we're pretty much done, but again, don't miss this. This is what we're trying to do. How do these numbers play into that line? Same as that one. It's already solved for y, that's fantastic. The terms are in order on the right-hand side. I got my x's, I got my constant. Check out how it works, it's so cool. You can graph lines in like 5 seconds. This constant literally tells you your y-intercept. Just cover up the x. By covering up, you're plugging in 0 for x. It's giving you 3. Right there, 3. Look at the interplay between point to point. That's what the slope tells you. This tells you go up 1, go right 2. Up 1, right 2. Up 1, right 2. So if we use that later on, if we use the fact that this will always happen if you solve for y, and I've explained to you how that works, then we can avoid all this stuff. Now, you might like this right now because it's fairly easy. I mean, you're just plugging in points, you're plotting them. But easy doesn't mean efficient. Efficiency is getting the right answer quickly, not spending a lot of time on it, and avoiding mistakes. This is prone to mistakes, especially when we're dealing with fractions and negative numbers. So I'd like to get us to the point where we don't even do this like ever again. Graphing without plotting. That's what we're trying to do. That's the goal of this video, is for you to see the interplay between these two numbers, the fact that we have to have it solved for y to use those two numbers, how these two numbers play into these lines. Now, one last thing I want you to look at. Do you notice that one of these lines is climbing and one of these lines is falling as we go from left to right? The slope will tell you that. We talk more about it later on, but just so I'm kind of previewing. I always like to teach a couple videos ahead of where we're doing to preview the information. Anytime your number in front of x, your coefficient, this slope, is positive, your line will be climbing from left to right. Anytime the number in front of x, your coefficient, that slope is negative, you will be falling from left to right. That happens every time, and of course you have to, because that negative is associated with the top number. That top number tells you whether you're going up or down. If you're going down and right for negative, your line's going to be falling. If you're going up and right for positive, your line's going to be climbing. That's why the slope gives us increasing or decreasing lines. That's pretty much it. That's the idea. Next time, what we're going to talk about is a little bit more about this. I'll give you some other scenarios where they're not solved for y. We got kind of lucky on these two. They were both solved for y. So next video, we're going to solve for y, and then we'll do basically the same thing, but I'm going to have you start looking at this a little bit different. So that's the idea. I hope this makes sense. Walk through these examples a couple more times, specifically looking for how these numbers relate to that line, and I'll see you for the next video.